Hello again. We are looking at problem number 4 in section 10.6 of your textbook for geometry part 2. This is found on page 653 of your textbook. Now, before we actually do the problem, it's imperative that you understand this particular rule here. And so what we're going to be doing is we're going to find arc length. Now, arc length it's not the measure of an arc like we've dealt with before. That's always the same as the central angle. So if that were 80 degrees, the arc would be 80 degrees. We're literally talking about the length of the arc. Now, we know that all the way around a circle is called its perimeter, but in this case we call it the circumference when it comes to a circle. So the circumference of a circle is all the way around a circle. But we're not wanting to know all the way around. We're wanting just to know around this piece of it or this arc of it. Now, in order to do that, we're going to take the circumference of a circle, which is 2 pi r, or if they're giving us a diameter, you would pick pi times diameter. Either one of these help you find the circumference of a circle. 2 pi r is probably the more familiar one, but you also can use pi times diameter. And the reason for that is the 2 and the r, twice the radius is the diameter. So that's why both of these would work. Okay. Now, we're not wanting to find the whole way around the circle. We're just wanting a part of it. And so what we do is we take the measure of whatever arc we've got and we divide that by 360. Because remember, 360 would be all the way around the circle. So we're trying to find what fraction of the circle we're actually looking for. And so that's why we write it like this. You're going to take the measure of the arc and divide it by 360. That's going to tell you what fraction of the circle we're actually talking about, times the circumference. So we're finding the fraction of the circumference of the circle. So that's why this formula looks the way that it does. Okay? So if you will, let me slide this down just a second. Let's look at number 4 here. Number 4 says, what is the length of each of the arcs shown in red? Leave your answer in terms of pi. Now this means to leave pi in your answer. Don't put it as a number, 3.14 in your calculator, or hit the pi button on your calculator. Leave pi alone and just do all the other calculations. And we'll show you what that means. Okay, so we're looking right here at this piece of the arc. Okay. Now, it doesn't tell me what the measure of that arc is, but in some ways it does, because that little symbol right there means 90 degrees. And if that's 90 degrees, then this is 90 degrees. So I'm going to take the measure of the arc and divide by 360, just like the formula said to do. So I'm going to take 90 out of 360. That's going to give me what fraction of the circle I'm talking about, times, now, because it gave me the whole diameter here, I'm going to use the second formula up there, which said pi times diameter. So 90 out of 360 equals pi times 16, which was the diameter. And so with your calculator, only do the 90 divided by 360, which actually reduces to 1/4, and 1/4 of 16, your calculator will do all this for you, but 1/4 of 16 ends up being 4. Notice I didn't put pi, just bring pi straight down and leave it as part of your answer. That's what it means, is leave your answer in terms of pi. It means don't calculate the pi, just leave pi in the answer. So the answer to this one is the length of from here to here, the length of that is 4 pi inches long. Okay. Now, the other formula, say for instance we're looking at this red one, it tells that arc is 240 degrees. So again, to find what fraction of the circle that actually is, take 240 and divide by 360. And then, because you're only given a radius here, you're going to multiply by 2 pi r rather than pi times diameter. Okay? Because you were given the radius. So 2 times pi times 15. Again, load everything in your calculator except for the pi. Just bring it straight down. Take your 240 divided by 360, multiply it by the 2, and then also by the 15. When you do, you should end up with 20, and as I said, bring the pi straight down. So the length of this piece of the circle is going to be 20 pi centimeters long. Okay, so let's look at number 4 real quickly. They got it. What is the length of the semicircle with a radius of 1.3? Leave your answer in terms of pi. Now again, think about this. If you have a circle here, the very word semicircle means half of the circle. Okay, so if you've got a half of a circle, then I know it's going to be 180 degrees. So I'm simply going to take the 180 degrees divided by 360, that's going to end up being half, because that's what a semicircle is. It's half of the circle. You're going to multiply that by, again, this time it gave us radius, so I'm going to use the 2 pi r. So 2 times pi times 1.3. Okay? And when I multiplied all of that together, 180 divided by 360 times 2 times 1.3, it ended up being 1.3. And then, of course, bring your pi as part of the answer, and then make sure your units are attached. So the answer is going to be 1.3 pi meters in this particular case. All right? It's just giving you a chance to use that formula, so please make sure to refer back to that formula when you need it, and after a while you'll get used to that formula and you'll be able to do it without having to look back. Best of luck.